All right, so let's get into today's lesson. Today we're going to be talking about Pythagoras. And normally when we talk about Pythagoras, guys, they will give us some sort of coordinate. Let's say, for instance, they will say to us that sine of theta is equal to 7/13. Okay, 7/13. Now, what this actually tells us, the 7/13, is that there is some coordinate on our Cartesian plane here, right? And we know that sine is actually y/r, right? So I know that whatever value that I've gotten over here, my y value is 7. And the radius from the origin all the way to that point over there is 13. That's what that's actually telling me, right? So we then know that if we put all of this together like that, this side is actually 7 units long. And if we know what the y value is, we can easily work out what the x value is. How would we work out what the x value is, guys? What would we use to calculate for the x value? Any ideas? Good. Oh, not the quadratic equation. I agree with Tando here, Hillary. That's it, Patu. We would use Pythagoras, right? Because this is technically over here, this is a right-angled triangle. So we can use Pythagoras here to get to the thing that we want. So we can then say x is just the square root of 13 squared minus 7 squared. And if we punch this into our calculator, I believe 169 minus 49 should give us how much will this give us, guys? 169 minus 49 will give us the square root of 120, something like that. Root 120. Am I correct, teacher Nels? Root 120? Yeah.
Yeah.
Root 120, but I think your calculator would possibly not rationalize that. They would take out a root, and that should give us, okay, I'm not going to guess. It's root 120, but your calculator will do the things that need to be done. All right. Hillary, I'm not sure about 49. How did we get 49, my sweetie? Just want to write this over to the side here. 13 squared minus 7 squared, okay, is equal to the square root of 120. Okay, all right, so I've already gotten to the answer, Hillary. I think we're a bit late there because I've already gone all the way and gotten the answer. Okay, so the square root of 120 is what we would get. All right, so this is some angle theta. Remember, theta is the angle that our coordinate or the radius makes with the x-axis, this part over here, which can also be counted in degrees going around our circle. So 0 degrees, that's 90 degrees, 180, and 270. 270 over here, and back to 360 over here. Now, the issue isn't this, because we've seen this before. We've done it since grade 7, grade 10. There's no issues with what it is that we're doing over here. We've done it before. The issue now starts when they say to us that we've got the sine of theta is equal to negative 7/13. And they say to us that theta lies in between the values 180 degrees and 360 degrees. All right, so now we have to consider where this could possibly be true. Okay, in fact, okay, let me change this up because this is going to give us an issue. Let me make this 90 degrees and 270. All right, so we know, guys, that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right. We also know cos is positive here. All of them are positive here. Sine is positive here, and tan is positive here. Now, if we want to look at this value that they've given us over here, they're telling us that sine is -7/13. Our value for sine is negative. Let's think about this, guys. Where is sine negative? In which two quadrants is sine negative? So how's like already jumped the gun, like woof, went all the way to the end. Okay, it's gone all the way to the end. But you're absolutely right, Sahau. Okay, sine is negative in the third and the fourth quadrant, right? Third and fourth quadrant. However, we know that our parameter has only been defined between 90 and 270. So we can't use the 270 to 361. So this one is also out. So the part where we actually need to draw this -7/13 is in the third quadrant. Okay, and so how you're 100% correct. Okay, so we're going to draw it in the third quadrant, which means that I must then start at my origin, going in this direction here. Right. Shoo, I almost went that way. I'm going in the wrong direction. That one there. Yeah, there we go. All right, we know that this is now 13. Remember, my radius will always be positive. I'm going to answer your question just now. Okay. Or teacher knows is going to do it in just a second. This becomes -7. And even though we've calculated that our x is equal to the square root of 120, what do we know about this value right there where we've put it at the moment? Okay, what do we know about that value there, guys? Good, Nolutando, 100%. It's negative. Okay, because it is an x value, but it's sitting on the negative x value side. So this must then become negative as well. It's sitting on the negative x value side. So it must be negative. Now, I think Onaza asking, ma'am, do we need to do the general solution here? No, we do not. Because they've given us our parameter, we're only going to get maybe 1 or 2 answers in that particular space. So we don't need to add the plus k times 360. It doesn't apply here because they only want the values for theta that are in between this section here. Okay, so there will be no 3k times 360. It won't count. They only want that one. Okay, so we don't have to do that. All right, just give me a thumbs up in the chat if everything that we've just discussed makes perfect sense. Okay, are we all happy? Excellent. Excellent. All right, let's get into some questions. All right, let's start with this question over here. It says, if tan of theta is equal to 3/4, right? But our theta has now been, it has now been defined for us in the quadrants 180 to 360. Calculate the values of, we're going to talk about sine 2 theta, cos 2 theta, and tan 2 theta. Now, I'm going to draw my Cartesian plane. Right. If I draw my Cartesian plane, let's think about this, guys. It says here that it wants tan of theta. And we know that tan of theta is positive in the third quadrant and the first quadrant, in those 2 quadrants. However, I can only consider my values for tan that are positive between 180 and 360. So the first quadrant isn't going to work because the first quadrant isn't there. My only option is my third quadrant. Now, my other issue here is that both of my values are positive over here. What do we know about my x and y values in the third quadrant? Anyone know? Good. That's it. That's it. They're both negative. They're both negative. But we know that if we divide them one over the other, we're going to get a positive result. So what they've actually given us isn't tan of theta is equal to 3/4. What they've given us is that tan of theta is equal to -3 over -4. Okay, that's what they've given us here. So we can then draw. Okay, my x values are going to be, my x is -4 and my y is -3. Okay. So this is -3 over here, and this is -4. We can very quickly calculate for my radius. Anybody got an answer for my r for me? R is equal to? That's it. Sure, you guys are very fast with these. Good, yes, Trish, that's it, Nkanaza, excellent. They are equal to 5, or r is equal to 5, good. Now we want to consider sine of 2 theta, cos of 2 theta, and tan of 2 theta. I'm going to give you guys about 5 minutes to go ahead and find me the answers for these 3. I will give you a little bit of time. Okay, go for it. When you're done, I'm not sure if Teacher Lee has you guys write done in the chat, but for me, whenever you're done, you can pop your favorite emoji in the chat. Okay, 5 minutes, guys, go for it. No, is that your answer for A? Because if it is your answer for A, we might need to look again. Be very careful. All right, guys, I think that's an okay amount of time. We should be able to do this in a little bit less time in any case. All right. Ms. Woody, is that your favorite emoji? I love to see it. I love it. Okay, so here's what we can do to answer this question, guys. So first thing we can do is we can go to our calculator and we can go shift tan of 3/4. And that's going to give us some arbitrary answer, like 36,54 degrees. Okay, and then we can go back into our calculator, and then we can go here and we can go sine, this is question A, sine of 2 times 36,54 degrees is equal to, and my calculator should give me 0,71, something like this for an answer. Is this correct, guys? Is this how we're supposed to answer this type of question? Now, Lutando says no. I want to see if anybody else agrees with you. Trish says no as well. Okay. And for those of you who say no, you need to explain to me, what have I done? What was I supposed to do? What was I supposed to do? Because I agree with you guys, but you'd be surprised we just finished marking exam papers and this is the kind of things that we saw. Okay, this is definitely not what we're supposed to do. All right, what were we supposed to do in this case? Okay, good. We were supposed to use trig identities, or more specifically, we were supposed to use our double angle identities. That is it, Nolutando. Well done, Trish. Well done. I think it's how? Yes, excellent. We're supposed to use our double angles. Now, I'm giving you a summary of our double angles. I don't really think we need to have them because we should know them off by heart. But we can then use we can say here that sine of 2 theta is equal to 2 sine theta cos theta. And we can put that into the calculator. Okay, or you can just do it quickly in your head if you're really good at mathematics. All right, sine of theta would be y over r, so that would give us -3/5 multiplied by cos of theta, which is -4/5. And the answer I should get here is 24/5. Oh, did they say no calculator? Yes, without the use of a calculator. Thank you, teacher Nels. No calculator. But I mean, it's matric.
Between you and me.
I'm just saying, nobody's really checking if you're really using your calculator. There's no calculator police sitting there going like, hey, they said no calculator. Okay, they're not going to be there doing that. All right, when we look at B, they ask for cos of 2 theta. And you are welcome, guys, to use any of the cos theta double angle identities. Okay, I like using the first one because I don't like minusing by 1, especially when there's a denominator and then times 2. No, it's a lot for me. So I'm just going to use the fact that cos 2 theta is equal to cos squared theta minus sine squared theta. That's the one I'm going to use. So that will give me cos 2 theta is -4/5 all squared minus -3/5 all squared. And this will give me 16/25 minus 9/25. And that is equal to 7/25. All right. Now, in order for us to answer tan theta, we need to remember that tan has its own identity. We know that tan of 2 theta will translate to sine of 2 theta over cos of 2 theta. And that is equal to, we don't have to then do the double angles again. We've already done it. We know that sine of 2 theta is equal to 24/25 divided by 7/25. And if we clean this up, we're going to find that our answer is 24/7. All right. Tell me in the chat, out of 3, how much did we get for the sum? 1 out of 3, 2 out of 3, 3 out of 3. What did we get? All right, now only got 3. I'm seeing a lot of 3s. There's a 1. Keith, do you know where we may have missed it a little bit? Guys, if you didn't get 100% for this particular section, I hope we know where we may have blundered a little bit. Okay. I hope we're seeing where we've blundered and we're not just forgetting to look at our corrections and our errors and make sure that we're doing them correctly. All right, excellent stuff, guys. Awesome. All right, here's a bit of a more difficult one. I want you guys to go ahead and try and solve this one yourselves. I'm going to give you another 5 minutes. Okay, again, pop your favorite emoji in the chat. Okay, I'm going to start by popping my favorite emoji in the chat because this is it for me, this one. Love this emoji because every maths lesson is lit. That's why. So I love the fire emoji. So go for it, guys. Answer questions A, B, and C. Remember to put the context, to put this whole thing within context as you're doing it. All right. How could you ask such a thing? I technically, Kateho, I should say no, but I'm feeling generous today. I'll give them to you. There they are. Okay. I should be like, no, Kateho, this is exam settings. No formulas, but I'll give them to you anyway. Okay, there we go. See, I'm so humble and so gracious. I'm a very giving somebody, you know. Just give them to you. Yeah, they do. They do. I'll admit they do give you the formulas and Konizer. They do. But remember, formulas are there to remind you. They're not there for you as a crutch for you to hold on to for dear life. Okay. It's not like you're hanging on the side of a math cliff and somebody throws you a rope. No. You are already stable, and every now and then you can't remember, oh, was it a plus or a minus? Then you use the formula sheet that they've given you. Okay, so just make sure that you're not leaning on them completely. You're just using them to help a little bit. Okay. One more minute. All right, guys. Okay. You can pop your answers to question A in the chat quickly. Okay, I'm just going to contextualize this for us so long. You can pop your answers or even your favorite emojis. Okay. Right. So now they tell us that they've given us 3 cos theta is equal to √5. So what I'm actually going to do is I'm going to divide both sides by 3. That's what I'm going to do so that the 3 disappears on that side. So I'm going to get that cos of theta is equal to √5 over 3. And I know that cos of theta is x over r. And they've also told me that my theta is only defined between 180 and 360, which means that if I want it to be positive, because both of these are positive, I'm going to need a positive x value, which means it must be in the 4th quadrant. So this thing should be over here. And I know that my x value is going to be the square root of 5, and my r value is going to be 3. With this being said, I can then calculate for my y value in this case, right? So I can then say that y squared, and let me not even say y squared, we're going to go straight into y is equal to the square root of 5, oh, I'm lying, 3 squared minus 5 squared. Ooh. Okay, 3 squared minus the √5 all squared. Okay, and this is going to give me the square root of 9 minus 5, which is in fact the square root of 4. So this side over here is 2. But what do we know about our value of y over here? This is going to be a negative value because my my y values are underneath. Okay, they're here in the negative y space. So my y value is going to be -2. All right. So from here, remember, guys, our theta is always around. There's our theta there. We need to contextualize our theta. All right. Now we can answer the questions. Sine 2 theta. Now we're going to use the double angle. Sine 2 theta is equal to 2 sine theta cos theta. And that is equal to 2 multiplied by my sine of theta, which is -2 over 3. And my cos of theta, which is √5 over 3. And all of this is going to equal to -4 √5 over 9. That's my first answer. Okay. -4 √5 over 9. And then we can calculate for B. Cos 2 theta, again, it doesn't matter which double angle you use, they're all going to give you the same answer. I'm going to use cos squared theta minus sine squared theta. And that will equal √5 over 3 all squared minus -2 over 3 all squared. This is going to give me 5 over 9 minus 4 over 9, which is equal to 1/9. All right. Then again, in order to find tan of 2 theta, I'm just going to take sine 2 theta over cos 2 theta. So tan of 2 theta is equal to sine 2 theta over cos 2 theta. And this is equal to -4 √5 over 9 multiplied by 9 over 1. Okay, I'm just going to go ahead and multiply, so that will cancel. And my final answer will be -4 over -4 √5. All right, give me a thumbs up or give me a mark out of 3. How much did we get out of 3 for this one? Let me know, guys. Good, I'm loving the 3 out of 3s. We're seeing our mistakes, which is awesome. Okay. Yay, Keith. I don't know why you're crying, Keith. I hope those are tears of joy. I hope they're tears of joy. Okay. I'm loving to see it. For those of you who got 2 out of 3, I hope we see where we're going wrong. And if not, please don't hesitate to ask a question or to raise your hand so you can unmute and ask a question just to make sure that you're understanding everything 100%. Okay. Now I want us to do Okay, I don't know if yes, okay, let's do this kind of question very quickly. Okay, and then we will get to the in terms of question right after this one. All right, I want us to do the same thing with this question, but I want you guys to be very aware of the fact that they have not given us the angle A. The angle A is not what they've given us. What they've actually given us is the angle 2A. Okay, so be very careful in how you define each of the things that you need to define. Okay, I'm going to give you guys 3 minutes for this because A and B are going to go by very fast. Okay, but sign like C is not going to be as easy. And when you're done, please guys, show me what you've got in terms of emojis. Let me pick another emoji. Let me see. I love emojis, guys. They're my thing. That just shows that I'm a millennial. The fact that I just love emojis. I'm such a millennial. Where's our slay queen? Our slay queen. You know the one we always use in our class teacher notes. Where is it? The slay queen with the fingernails. I need to look for it now.
Yeah.
I must find it. Oh, there it is.
Maybe type hands. Oh no, it's not.
Yeah. Because the slay queens are in the house today. No, I mean.
I don't know, but
No.
no.
Is it just me? Okay, fine. Awkward silence. Okay.
Yeah. The like the problem, not slay queens. Just one queen.
Just me. Okay, it's fine. I'll accept it. I accept it with grace. Thank you.
I'm all about the flowers.
Okay. Fine. Fine. Be like that. That's cool.
You sent the fire emoji. I almost sent the ice cubes. I wanted to have. I searched for it. I found it. I was like, let me not. Let me not. I was gonna put out the fire.
How dare you? Turning into Mirula in 1 second. A few minutes. Yeah. He's a bad influence, by the way, teacher Lily.
I feel like this class is like so serious and focused. We're all about the maths.
Love to see it though.
Which is good. Metric is just 1 year, like that would decide like your whole future. So I think it makes sense to just, okay, forget about everything else. Let me just focus on my status. I ain't got time for jokes.
Yeah. But then again, we are kind of old and cheesy. So I don't know, maybe it's our jokes. Who knows?
Yeah.
All right, 1 more minute and then we're going to get started. All right, guys, I'm going to call it. All right, let's have a look at these questions over here. All right, so they've defined sine of 2a for us, but they've told us that 2a lies between 90 and 270, which means that it should lie either in the first or the second quadrant, but we know this first quadrant is not included, so it's definitely going to lie in the second quadrant, right? So I know that sine of 2a is root 5 over 3, which is the same as y over r. So if I draw this over here and draw this down, I know that my y value will be root 5 and my r value will be 3. And then if I calculate for my x value, I'm going to get that my x value is -2. Just give me a thumbs up or say yes, ma'am, if you got the same thing. Okay, you can just calculate for x is the square root of 3 squared minus. Excellent, guys. Awesome. All right, there we go. Okay, so we should get -2 as an answer for our x values. Excellent. All right, so let's start with A. Now, A says they want the sine of 2a. Oh, sorry, the cos of 2a, right? Now, the thing is that we don't have to use a double angle here. We don't have to, because they're already asking us for cos of 2a, and we have sine of 2a. Therefore, cos of 2a is just going to be -2 over 3, because that's x over r. Bonga says, sorry, I just joined. How did we get -2? We used Pythagoras, Bonga. So we can say x is equal to the square root of the radius squared minus the y value squared. Okay, if you do that, because they've given us the radius and the y value, you can find the x value. But because it's on the negative x side, we need to use -2 instead of +2. All right. Okay, same with B, guys. B, we just want the tan of 2a, so this shouldn't be too difficult at all. That is going to be y, which is 5 over 2. I mean, 5 over -2. Y over x, which is 5 over -2. Now, when we get to C, then there's a little bit more work to be done here. Because they haven't given us 2a over there, they just want sine of a, we can then do this. We can go sine of 2a is equal to 2 sine a cos a. So now we're going to have to do two things here, guys. We're going to have to do two things. We're going to have to then define two things, or have I lost my mind? Yes, we're going to have to define two things. So let's not use sine of 2a. Let's use cos, because then we'll only have one thing that we need to define. All right, let's use cos of 2a. Okay, cos of 2a. Okay, so I'm only going to then look for 1 minus sine squared a. Right, but because I want sine of a, I'm going to make sine of a the subject of the formula. I want this thing to be the, oh, 2, sorry, I left out a 2, didn't I, teacher Nels? I did. This is 1 minus 2 sine squared a, like that. Yes, okay, so we still want, regardless of that, we still want sine squared a, or sine a, as the subject of our formula. So we're going to take everything else, move it over to the other side. Okay, so we will then get cos of 2a minus 1 divided by -2 is equal to sine squared a. And then if I want sine of a, I then have to take the square root of both sides. Okay, square root that side, and we get rid of the squared there. So my sine of a will then be equal to cos 2a, which we've already calculated for. That would give us -2 over 3 minus 1 over -2, the square root of all of that. All right, so we can then, it says without the use of a calculator, so we can just then try and figure this out. Ooh, -5 over 3 divided by -2. Yes, teacher Nelson, am I correct here? Yes, yes. All right,
Yes.
guys. Yeah, don't judge me, né? Guys. I don't like fractions, so I'm gonna do them the old way. I'm gonna go tip and times, guys. Né? No judgment. No judgment, because I've sucked at fractions for the longest time in my life. So if I tip in times, if I tip in times, this is going to give me 5/6. Thank you, Tando. Thank you, Tando. I feel so much better when I hear you guys say that. So the answer is going to be the square root of 5/6. Thank you. I love that you guys have not judged me. You know, guys, the struggle is real. I've struggled with them since school, so I tip in times. All right, that's the one question that we got. That is the final answer. A mark out of 3, guys. Let me know how much did we get here. Gwena got 2. I knew this one might be a little bit more difficult. I agree. Okay. Oh, Ganesa got 3. Well done. That's amazing. Very, very well done. This was a bit of a tricky and difficult one, but it's good that you were able to figure it out. Well done. Excellent stuff. Sure. That's okay, Keith. We keep it moving. We're learning from what we're doing today, and that's going to help us get a lot stronger in the future. It's better to make the mistakes now rather than like in an important test or something. Let's make mistakes here. Okay. All right. So Teacher Lee has left this for homework for you. So I'm going to give you guys 5 seconds to take a screenshot of this for homework, and then we're going to move on to something else. All right. Take a quick screenshot. 5, 4, 3, 2, 1. All right, we're done. We're going to be looking at this now. All right, we're going to be solving a problem in terms of P. All right, so the question, let me just make it a little bit smaller. It's a lot. It's a lot. I'm going to make it just a teeny bit tinier. All right, there we go. Okay, so the question that we've been given over here, guys, is still the same as what we would do if we were on a Cartesian plane. There isn't really anything different here. We're still going to be using a Cartesian plane. We're just going to be smart about it. Okay, we're going to be smart about it. Now, they're telling me that I've got sine of 34 degrees, and this is equal to P. Now, because I know that sine of theta is y over r, I'm going to then rewrite sine of 34 as P over 1. Okay, so I know that this is positive. It's all positive. They haven't really told us what quadrant to put it in. I'm going to put it in the first quadrant to make my life easy. So I'm going to put it right there, like that. This angle over here is 34 degrees. And I know that sine is equal to y over r. And that means that this over here is P, and my r value would be 1. It's 90 degrees. All right. I want you guys to answer 26.1.1, 26.1.2, 26.1.3. Right. If you need any help, please make sure to just pop in the chat. Ma'am, I'm a little bit lost. Please help me out. Where do we go from here? I'm here to help. Okay. Try this question out, guys, and let me know. I'll give you a hint. The smart thing to do is figure out what my x is. Find out what x is. It will make it a lot easier. Oh, one last thing. Sorry, I forgot, guys. Okay, our question says that you must determine the value of each of the following in terms of P, which basically means my answer must have P in it. Okay, my answer has P in it. That sounded terrible, but you guys know what I mean. Okay. Lerato, is that one of the answers, that 2 that you've given us there? Or is that something different? One more minute, guys. All right, I'm going to call it. Otherwise, we're going to run out of time. All right. Pop your answer to number 1 in the chat, guys. Let me know what it is that you got. All right, so I know that if I have sine of 214, I can reduce this thing, right, to sine of 180 plus 34, right, which is equal to, that's it, Masejo. Good. Right, and this is going to give me negative sine of 34 degrees. And this is the same as negative p. Well done, guys. Amazing. Awesome stuff. Awesome, awesome. All right. If I look at point 1.2 over here, I'm just going to clean this up a little bit. I know that I'm going to get cos of 34 degrees, and cos of negative 22 will still fall in this quadrant, so it'll still be positive. So it'll just be cos of 22. Plus cos of 56 degrees. Now, sine of 338 is going to fall into the 4th quadrant, and it will reduce into sine of 360 degrees minus 338. Right, so I'm going to end up, I'm just going to finish down here. I'm going to get cos of 34 times cos of 22 plus cos of 56 times minus sine of 22, sorry. Okay. 22 degrees, right? That's it. Okay, this should give us P. Okay. Excellent. So what I'm going to do then, guys, is I'm going to take cos of 34 degrees multiplied by cos of 22. Yes, that's what I was going to do next just now, teacher Nels. Thank you. Okay, then I've got minus cos of 56 times sine of 22. Now I realize that I'm almost at a compound angle. I'm almost at a compound angle. The only thing that's making my life difficult right now is this duty over here, this cos 56 degrees. So what I'm going to do is I'm going to use a co-function, and I'm going to change cos of 56 degrees to sine of 34 degrees. Okay. So that's going to give me cos of 34 degrees times cos of 22 degrees minus sine of 34 degrees times sine of 22 degrees. And then I can just do the reverse of the compound angle. This is the cos compound angle. So this is going to end up as cos of 34 degrees plus 22 degrees. And this is going to equal the cos of 56 degrees. Okay. That's it. Seth, is it not the other way around? Or did I blunder somewhere?
Yeah, I think it's, oh, Oh, you changed it. How did you sine, so that would be cos, okay.
Yes, okay. Okay, hold on. Can we change cos 34 to sine 56? Yes, you can. Okay, then you can use the sine function because I'm about to end up in the same place, Seth. We're going to end up in the same place. Bonga says, how do we change negative cos 56 to negative sine 34? All right, Bonga, remember, we have cofunctions that say cos of 90 minus theta is equal to sine of theta, right? And sine of 90 minus theta is equal to cos of theta. So what I'm actually doing here is I'm taking cos of 56 and I'm saying I've got cos of 90 minus 56, and that's giving me sine of 34. That's what I've done. That's why I've taken this part here, cos of 56, and I've changed it to sine of 34. That negative that I've put in the middle now comes from when we reduced sine of 338. Because it gave me a negative. So I'm taking this negative over here and I've got negative times a positive will give me a negative in the middle. Does that make sense? Okay, that's okay, Bonga? All right, so now I've got cos of 56. I can do the same thing. I'm about to get there, Sehau. Okay, I can take cos of 56 and I can do the cofunction again. Cos of 56 is the same as sine of 34. And sine of 34 is equal to P. Okay, there's where we get the answer P. All right, I do realize that we could have taken this thing over here. We could have taken cos of 34 and changed that to sine of 56. And then we would have had sine cos sine. And then we could have done 56 minus 22, which would have landed us at sine of 34. And then you could have done that as well. Your answer would have ended up as P as well. Okay, so we can do it either way. Seth, you are 100% correct. We can do it the other way as well. All right, then we're going to notice with point 1.3 that cos of 68 is the double angle. Okay, cos of 68 is the double angle. Sorry, 26.1.3. Cos of 68 degrees. This is equal to the same as cos of 2 times 34 degrees, right? And this can then translate to any of the cos angles that we have, right? So yes, double angles. So then we're going to rewrite this however we want. Now, here's what I'm going to do, guys. I know for a fact that if I use the cos double angle with cos in it, I'm going to have to use that ugly thing over here that goes p minus 1 at the bottom. The square root of, 1 minus p squared. And me, I don't like it. I don't want to use that 1 minus p squared at the bottom. I don't want it anywhere near me. So what I'm going to do is I'm going to use the one with sine in it because I know that sine is just p over 1. And I like using just p. So I'm going to then change this to 1 minus 2 sine of 34 degrees. And that makes my life so much easier because sine of 34 degrees, sorry, I'm squaring this, yes? 1 minus 2 sine squared. Look at me. I was busy judging Katleho and now I need to go look at my own double angles to make sure I'm not lying. Yes, yes. Yes, we're squaring it. Sorry, no, but I was only checking if it's sine, if it's squared. So at least I'm justified. So we're going to get 1 minus 2 times p squared. Okay, I can just write 2p squared. Okay, 1 minus 2p squared. There we go. All right. Okay. Again, this is a lot of marks, guys. So you can mark yourself against the mark scheme, or you can just tell me if you got all 3 questions correct. Okay, you can give me a mark out of 3. We're not going to belabor it too much with the marks. When Teacher Lee is doing a bit more extensive work around trials, she'll start helping you guys with mark order.